Hi, welcome to SQL Server 2012 Always On session. I'm Min Hee, Program Manager of SQL Server Engine. Today I'm going to talk about Always On failover cluster instance and related HA enhancements. This is today's agenda. Firstly, I will talk about what is Always On and what is failover cluster instances. Then I will go into details about 4 enhancements we made in SQL Server 2012. The first one is multi-subnet clustering. Then I will talk about the storage enhancement. The third enhancement is predictable recovery time. The last one is flexible failover policy. So what is Always On? Always On is the integrated high availability and disaster recovery solution we provided in SQL Server 2012. So Always On have 2 technologies. The first one is availability groups. We also call it AG. So Always On AG is based on non-shared storage, which means you don't have to use the SAN storage. You can use your local disk to store your databases. And AG provides database level high availability protection. And also there's no active passive concept for Always On AG. All the secondaries can be active, which means can provide you read-only access. Another Always On technology is failover cluster instance. We also call it FCI. So FCI is a shared storage solution, which requires you must have a shared storage. For example, Fiber Channel or iSCSI. FCI is an active-passive model. So you will have one active node and multiple passive nodes for each instance. If the active node has any failures, the instance will fail over from one node to another node. Therefore, you have instance level HA protection. Okay, now we know failover clustering is a shared storage technology, which is part of the Always On solution. Let's move to the first enhancement, multi-subnet clustering. Here's an example of how you can use SQL Server 2008 R2 FCI to create your disaster recovery deployment. So you have 2 data centers. On the local side, you have 2 cluster nodes, Node 1 and Node 2. And you also have a SAN storage. On the remote data center, you have the same hardwares, Node 3 and Node 4, and another SAN storage. Between those 2 sites, you need to have a SAN replication solution, which usually provided by third party, to synchronize the data changes from one side to another side. And usually, one data center has one subnet. So your Node 1 and Node 2 on the subnet 1, Node 3 and Node 4 on the subnet 2. But SQL Server 2008 R2 has a limitation. It doesn't support 2 IP addresses from different subnets. So what you can do is you have to create a stretched VLAN to bring all the cluster nodes from Node 1 to Node 4 into the same subnet. Then you can create your network name mapped to the one single IP address. Let's say right now the Node 1 is the active node, which is hosting the IP address. Now if the power goes down, the whole local site goes down, the same IP address will fail over to the remote site. This is how you do disaster recovery with the SQL Server 2008 R2 FCI. The problem with the VLAN solution is that the VLAN solution maintenance is very complex. Another issue is usually the network administrator has concerns, security concerns, so that the network package from one subnet will go through the VLAN, stretched VLAN to another subnet. Stretched VLAN is not needed anymore with SQL Server 2012 because now FCI can support multiple IP addresses from different subnets. For example, when the primary node is hosted in the local site, it can listening on IP address 1, which is from the subnet 1. When something bad happens on the local site, the whole site goes down, the FCI failover to another subnet, then the FCI can listening on a different IP address from subnet 2. The virtual network of SQL Server instance can depending on both of the IP address with OR relationship, which means as long as one IP address can online, the network name resource can be online, and the SQL Server instance can be online as well. Let's have a quick look on how the multi-subnet clustering works. So here I have one cluster instance MS SQL Server. It's a default instance. There are two nodes. Node 1 is on cluster network 1. Node 2 is on cluster network 2. Those are on different subnets. So within this cluster resource group, we have the network name, which is the VNN. This network name resource is depending on two IP addresses. So the first one is from the subnet 1.33. The second IP address is from another subnet 2.30. So when the cluster active node is on node 1, then the IP address from the first subnet can be online. Now let me do a manual failover to another node, node 2. Now you can see the second IP address is online and the first IP address is offline. Let's have a look on the resource dependency. So you can see the IP address, two IP addresses with the OR relationship. So whenever one IP address can be online, the network name resource can be online. If you are doing integrate in cluster installation, you can specify the first IP address when you install the first node. When you add the second node, you can specify another IP address. The SQL Server cluster setup will detect if this is a multi-subnet environment. If it is, the IP relationship between the two IP will be set as OR. If you are not installing a multi-subnet cluster, then you need to go back to check your network settings. If you are installing a multi-subnet cluster, then click yes. Next, let's look at the multi-subnet clustering requirements. The first requirement is on the SQL Server Edition. So you have to use Enterprise Edition to use this feature. Also, your OS version should be SQL Server 2008 R2 or above. If you are using multi-subnet clustering for your cross-site disaster recovery solution, then you will need the SAN replications. For example, the EMC SRDF. Then another requirement is from the Windows cluster. Although your cluster nodes are from different data center, all those nodes have to be in the same AD domain. Next, we'll talk about the best practice. The first one is how should you select the quorum mode for Windows cluster. Second one is how should you tune the Windows cluster heartbeat. Then if you use SAN replication, how do you choose the replication level, or how do you choose the sync replication or async replication? The last one is the DNS settings, and also the changes from the client connection string. So how should you choose the quorum mode for your Windows cluster? There's a very simple rule. If you have even number of nodes, you should choose node and file share majority. Here's an example. You have 2 nodes on the local data center and another 2 nodes on the remote data center. So 4 nodes is an even number. You should set up a file share here so that you can have 5 nodes totally. In this way, when the local data center is down, you still have 3 votes. 1 vote from the file share witness and another 2 votes from the remote data center's 2 nodes. So you can still keep your quorum for your cluster. If you have odd number of nodes, for example 2 nodes in the local data center and 1 node in the remote data center, you should choose the node majority. So node majority has a drawback. If the local data center goes down, then you will lose the quorum for your cluster. You have to do a false quorum on the remote side to bring the cluster up. If you are creating Windows cluster across 2 data centers, you might want to change the default Windows cluster heartbeat settings. Windows cluster use heartbeat to detect if a node is alive or is down. So by default, each node should send out one heartbeat signal for every 1 second. If Windows cluster cannot detect the 5 heartbeat from one node, it will determine that that node is down. If you have a bad network condition between your 2 data centers, a network glitch can cause you lost all the remote nodes. So you can do the following things. Increase the cross subnet delay. This number can be up to 4 seconds. And also increase the cross subnet threshold. This can be 10 seconds. So that your Windows cluster will tolerate longer time without having the remote cluster heartbeat. Next, let's have a look at the SAN replications. SQL Server only supports block level replications. Both the file level and application level replication is not supported. For block replication, the block size and write order has to be preserved. Otherwise, you will have data corruption issues. So the SAN replication mode choosing, we have the following suggestion. If the network latency between your 2 data centers is less than 10 milliseconds, this is typical for a regional disaster recovery solution. You can choose sync mode. Otherwise, if the network latency is bigger than 10 milliseconds, which is typical for a GODR solution, you should choose the async mode. So the last practice is for the client connection strings and DNS. When you install the multi-subnet failover clustering, SQL Server Setup will register all the possible IP addresses on the DNS server. So on the DNS server, you can see your network name mapped to the first IP address and another record, which is your network name mapped to the second IP address. So for your newer client, use the ADO.NET or JDBC. There's a new parameters introduced in SQL Server 2012, which is multi-subnet failover. So you should choose this multi-subnet failover equals yes. Then SQL client will try to connect to all the IP addresses in parallel, which can make your connection very fast. If you are using old clients or the OLADB clients, you should extend the client connection timeout by 31 seconds per additional IP. So if you have two IPs, then you should add 31 seconds for the connection timeout. Next, I will talk about the broader storage type support for FCI. In SQL Server 2008 and 2008 R2, FCI only support SAN storage, for example, Fiber Channel or iSCSI. In SQL Server 2012, SMB file share storage is also supported. So you can use cheap file server to do the database storage consolidation. Also, you can create more than 26 cluster instances in a single Windows cluster. One requirement is that if you are using Windows file server, the Windows file server OS has to be Windows Server 2008 or later version. So usually people will have the concern of the SMB file share performance. So there's a Windows KB 2536493. This KB fixed the performance issue of the file server. So right now you can see the SMB performance is very close to the direct attached storage, which is the local disk. Another FCI storage support change is that now you can put your FCI tempdb on local disk. So why we need this? If your application is heavily used temp tables, your tempdb access to the SAN storage could use large percent of your SAN I/O. And also the modern PC server will configured with very fast hard drives or even solid state disks. Using tempdb on local disk can give you a better overall performance. Also can save you the cost on the SAN storage. So you might consider to move your tempdb to local disk. But one important note is that unlike the shared storage, shared disks, Windows cluster will monitor the shared disk availability through the disk resources. Local disk is not monitored by Windows cluster. So you should to make sure that your tempdb local paths are available on all the cluster nodes. Otherwise, when you do the failover, the failover might fail. SQL Server 2012 also improved the mount point support. So right now you can put your data files on the root path of your mount points. In SQL Server 2008 and 2008 R2, you cannot do this. You have to create additional folder under the root path to put your data files. Also, setup now can automatically add the mount point disk dependency to the SQL Server resource. Next, let's talk about the HA-related enhancements. We all know after FCI failover happens, the total downtime includes two parts. One part is the time to start your SQL Server instance, and another part is the time to recover all your user databases. The time to start a SQL Server instance is a fixed time. Usually it can be done within 10 seconds. But the time to recover all your user databases is depending on how many changes you made after the latest checkpoint. The more changes you made, the longer it will be used for recover your database. Now we know to control the total failover time, we have to control the checkpoints. But with the previous SQL Server release, you have very few control on the checkpoints. You can only do fixed interval checkpoint. By default is 2 minutes. But within the 2 minutes, the change can be more, can be less. So you will got variance in the failover time. Also, when SQL Server is doing the checkpoint, you will see the I/O spike if you are monitoring your I/O load. In SQL Server 2012, we introduced a new feature called indirect checkpoints. You can configure for each your user databases how you would like the checkpoint behaves. And also the indirect checkpoints will do background checkpointing over time. It's not like a fixed interval. So you will get a smoother I/O load. Also, the failover time will be more predictable. Let's look at how to enable indirect checkpoints for your user database. I have two databases, DB1 and DB2. Let's have a look at the server level recovery interval first. The recovery interval is an advanced option, so we need to enable show advanced option first. Then SP configure recovery interval. You can see right now the recovery interval value is 0, which means it is using the default interval. And let's have a look on the user database recovery interval. So you can see DB1 and DB2 by default, they are using the server level recovery interval. Then I will set the indirect checkpoint for the user databases. Here I set the DB1 target recovery time as 10 seconds. And for database 2, I set the target recovery time as 1 minute. Let's have a look at the database level recovery interval again. So you can see after change the indirect checkpoint, your database 1 have the target recovery time in seconds as 10 seconds. Database 2 has using a 60-second recovering time. Next, I will talk about the last FCI enhancements, flexible failover policy. Before we talk about the failover policy, let's have a look how SQL Server is doing health detection. SQL Server has a resource DL, which is responsible for reporting the SQL Server health state to the Windows cluster. So when the resource DL want to know the SQL Server health state, it will issue a select at server name. If the SQL Server returns the server name, then resource DL will report to the Windows cluster the SQL Server instance is alive. So this is a very simple pull mechanism, and it depending on the query processing. The problem with this health detection mechanism is that when the SQL Server is very busy, the query to select the SQL Server name could time out. When the query is time out, resource will try to establish another connection, and the connection could be also failed because the SQL Server is too busy. Then the Windows cluster will consider the SQL Server as failed, then trigger a failover. But at this time, the SQL Server is very healthy and busy with the user workload. So we call this is a false failover. To resolve the false failover issue, SQL Server 2012 now replace its way to do the health detection. The resource there will call a store procedure called SQL Server Diagnostics instead of query the server name. This new store procedure will keep pushing back the SQL Server health state to the resource DL. And also, even the SQL Server is very busy, this store procedure can guarantee the health status is returned to the resource DL because it is running in a high priority thread. So the diagnostics information also include all the important SQL Server component state. Based on the different state of the component, now you can configure the failover condition to define how the SQL Server responds to the different type of internal failures. All the server component health status will be saved as the diagnostic logs, so that when the failover happens, you can use the diagnostics logs to do your investigation. Now let's take a look at the new store procedure, SQL Server Diagnostics. This store procedure is a system store procedure. It can also be called by the DBA to do the system health detection. It can return the query processing failures like worker thread exhaustion, unresolvable deadlocks. It can also return the resource issues like a resource pool is out of memory. Also for system issues like internal errors, offense spin locks, memory squibers, frequent dumps. It also returns the I/O subsystem information and X events, but those two components is not used for the failure detection. SQL Server now allows you to configure the how frequent Windows cluster is running the health detection. By default is 60 seconds. The minimum number you can configure as 15 seconds. This health check timeout can control how quick the Windows cluster responds to a SQL Server failure. SQL Server now also allows you to configure the how Windows cluster responds to a certain type of SQL Server failures. So the default level is system failure. So only when the critical SQL Server error happens, the Windows cluster will trigger a SQL Server failover or restart. You can even disable the failure detection, but the diagnostics logs will always be captured. So let's have a look on the different failure condition levels. So the level 0 means there will be no automatic failover or restart triggered by Windows cluster. If you set the failure condition level as 1, then only when the SQL Server service is down, a failover or restart will be triggered. If you set the level as 2, then only when the SQL Server is down or there's no response from the SP Server diagnostics, which means the SQL Server is hung, then the failover will be triggered. The third level is the default level. So only when the system error happens or all the below error happens, a failover will be triggered. If you set the failover condition level as 4, then you will add the failover response for resource pool errors. If you choose the failure condition level 5, then when the query processing error happens or other type of error happens, a failover will be triggered. So the suggestion is that the default failover condition level should be good for most of the cluster configurations. If you are a experienced DBA, then you may consider set the failure condition level as 2. If you are doing some maintenance works and want to manually control the SQL Server failover, you can set the failover condition as 0. If you just want a Windows cluster reboot or failover the SQL Server when whatever type of the error happens, you can set the failure condition level as 5. Now let's have a look on the SP Server diagnostics, how it works, and also I'll show a demo of the SQL diagnostics logs. Now I'm already connected to the SQL Server cluster instance. I'm going to call the SP Server diagnostics with the 5-second repeat interval. Now the SP Server diagnostics will return the health status for every 5 seconds. So I click execute. This is the first set of result get from the store procedure. Now you can see we get all the health status coming from the store procedure. Unless I cancel this store procedure, it will keep pushing the health status back to the client. Now let me cancel this store procedure and show another demos. Here's the new DMV to show all the SQL Server cluster properties. All those properties are private property of the SQL Server cluster resource. You can see all the properties also from Windows Cluster Administrator. Let's have a look here. Click the property. From the properties, you can see a list of all the private properties. Here's the failure condition level is 3, and health check timeout is the default value 60 seconds. Now let me go back to the Management Studio, try to change the failure condition level as 5, and the health check timeout has 15 seconds. Now let's check the value again. You can see the failure condition level change as 5, the health check timeout change as 15 seconds. Let's go back to Windows Cluster Administrator. Check here. Yep, the value changed. So you can see all the health policy changes will take effect immediately. You don't need to restart or reboot the SQL Server instance. Now let me show you how to use Management Studio to read the SQL Server diagnostics logs. Let me close this. So the SQL Server diagnostics logs is by default will be in the SQL Server log folder. You can see the log is named by the node name and instance name, and followed by the SQL tag and timestamp. I will open a sample log file which contains the warning message in it. So open this file. By default, it will show only 2 columns. You can choose the column here, so you can see all the columns, the component state, the state description, and the data, and also the, let me add the node name here, and also add the instance name here. It will list all the states and the data here, and also you will have the detail, what is the time of the log, and the detail data. Double click, you can see the details in the XML format. You can also add filters. For example, if I just clear the warning status, let me add a filter. Use the state equals 2 should be the warning, and I also want to see if there's any arrow state. So change this to or state equals 3. Okay. So we'll find there's just one warning state. So double click the data column, you will see the warning. Let me summarize the always-on failover clustering enhancements in SQL Server 2012. The first enhancement is the multi-subnet failover clustering. So it can save the cost of maintaining a stretched VLAN. The broader storage type support, you can use SMB file share to do your database consolidation and also your instance consolidation. By moving your TempDB from the SAN storage to local drive, you can save the cost of the SAN storage and you can get better overall performance. Right now, the SQL Server 2012 have better mount point support. So you can now put your data files on the root folder of your mount point, and the mounted disk can be automatically add as dependency of the SQL Server resource. With the flexible failover policy, now you can control how the Windows cluster responding to the SQL Server failures. And also, SQL Server now have a very reliable and precise health detection. Also, with the SQL diagnostics logs, you can do a very easy failure cause analysis within the management studio. With the indirect checkpoint, now you can set the target recovery time for each of your databases based on your RTO. That's all for today's content. Thank you for listening. Bye bye.